Welcome to GATE class on analog electronics. And now myself I am introduced first. I am Megala, Associate Professor in SAEC Engineering College. Now I am going to take the subject GATE related for the electrical and electronics department point of view is analog electronics. From that analog electronics, the three subjects are covered in these subjects. One is electron devices and circuits, another digital electronics, the last one is linear integrated circuits. Now I am going to take that linear integrated circuits, the basic things of operational amplifier and its characteristics. Now we will go for that first one. What do you mean by the operational amplifier? It's nothing but the linear amplifier. It performs some mathematical functions like addition, subtraction, multiplications, integrator, differentiator, logarithmic, anti-logarithmic, and then filter designs, and you can generate the waveforms. So many applications we can use that operational amplifier. Now you can analyze that operational amplifier in a integrated circuits manner also. Now, so basically the integrated circuits, integrated means the collection of all the gates in case of the digital, or in case of the analog means you can say the resistance, inductor, capacitor, and then transistors also. So inductors is coming under the microwave integrated circuits, but here you can use only the resistors, capacitor, transistors, etc. for integrating the circuits, to make your integrated circuits. So the integrated ICs, like integrated circuits, is nothing but the IC we can use for the variety of applications like this communication, control application, instrumentation, controller, electronics point of view. Now coming to this operational amplifier. I said in that beginning, the operational amplifier is nothing but the linear amplifier. It performs some mathematical functions also. So this is that integrated circuit. It has the 8-pin dual inline package they will use to manufacturing this IC. These 8-pin ICs, the symbolic representation of this operational amplifier, these things. So for it has that two input, one is inverting, another one non-inverting amplifier. We can use that two biasing supply voltage, positive and negative biasing, one output. Remaining things we want to control that offset voltage. I tell you later in that offset voltage. Now, so in generally the operational amplifier IC, the number is 741. You want to analyze in a two different way. One is the normal ideal op-amp, ideal cases, another one practical cases. Now we can analyze this operational amplifier IC741 in a ideal manner. Ideal manner means there is no any input you are given. Okay, you can analyze that output, some parameters. So you want to analyze that ideal op-amp operational amplifiers. So this ideal operational amplifier means nothing but ideal cases. There is no any input you are given to the input terminal. Either is inverting or non-inverting terminals. So we can assume that these inverting terminal or non-inverting terminals current drawn is 0. So the output also we can 0. So based on that, the ideal characteristics are defined. So just you can remember the ideal characteristics. First one is the gain. Gain is nothing but we already familiar the words for amplifier, output by input. So the gain is infinity in case for ideal characteristics of an op-amp. So why is infinity means there is no any input current applied to the IC741 operational amplifier. So there is no input means the output is becomes 0. So the gain we already know, the gain is nothing but output factor divided by input. So that's why the gain is infinity. The next thing is the input resistance for the operational amplifier is infinity also. So the no current flowing to this input terminals, so that's why the resistance also input side is infinity. The next thing is there is no dry circuit from this output terminal. That means the output resistance is 0 because the output also 0 with input current is 0 conditions. Now the input voltage is 0, input current is 0. This is all that ideal characteristics of an op-amp. The symbolic representation, or you can say that equivalent circuit of IC741. So we are given that input terminal either inverting or non-inverting terminal. The resistance across the input terminal is input impedance. The output resistance taken from the output with respect to the ground terminal is output resistance. Now, so these are the important thing. This ideal characteristic, input impedance is infinity, output impedance is 0, and then voltage gain should be that infinity in ideal cases. Now, next we can go for that DC characteristic. You want to analyze the characteristics of IC741 in a DC manner as well as the AC manner. What do you mean by that DC manner? DC manner means your ideal IC741 operational amplifier, inside it has the two-stage of differential amplifier, because you can assign two input terminal, inverting and non-inverting terminal. So two-stage of differential amplifier is there. Next thing is level translator, then output stage. These are the internal blocks of IC741. So you want to biasing the transistor, what we are using inside that fabrication integrated circuits. So you need the supply voltage, that is the positive voltage as well as the negative voltage. Now from that you can give your DC supply voltage to the IC741. So what are the characteristics you want to analyze it? So that is the DC characteristics of operational amplifier. First one, input offset voltage. Second one, input offset current. Third one, input bias current. Fourth one, differential input resistance, that means input resistance. The last one is the temperature variations. Due to the temperature variations, what will happen in that output of a IC741 operational amplifier, that is the thermal drift. Now, so first one parameter is input offset voltage. Input offset voltage means there is no any input here given to the inverting and non-inverting terminal. That means the difference of the input voltages is zero. That case, definitely the output voltage should be zero. But in case of the practically, it not be zero. So you want to minimize or you want to nullify that output voltage should be the zero in case of when the input difference voltages are zero cases. So we can apply the small differential voltage at the input terminal to make your output is zero when that input voltage difference is zero cases. Okay, that is the first one, input offset voltage. So in generally IC741, the input offset voltage is 6 millivolts. So you can remind these things. We want to solve that gate question papers. Sometimes they will not given that input offset voltage, bias current and input offset current also. So you can assume that the minimum value of the input offset voltage is 6 millivolts. So you can require the 6 millivolts to make your output zero when that input difference is zero cases. Now second one is input offset current. Input offset current means I said differential amplifier we can use inside that IC741. So differential amplifier having that two transistor, identical transistor anyhow is identical, but due to that similarity of identical, due to that defect of the fabrications, so the bias current, unwanted current will be flowing in the inverting terminals. This is not like a input terminal, input current is not like a original current. Okay, so some unwanted current will be flowing to the input terminal, that is you can say that is a offset current. So you want to find out that current, you can minimize, because this offset current to make your output is not equal to zero cases. So in without any input, or you can give a difference input voltage is zero, your output should be a zero cases only. But in case of the input offset current, what will happen, you can't able to make your output zero. So you want to minimize that input offset current, so we can use that feedback resistance along with some pi networks or T networks. I showed in that next videos. Now, so this is the formulas. You want to find out that offset current, the bias current flowing to that inverting terminal and non-inverting terminal, its difference is called as the offset current. So the difference between the bias current flowing to the inverting terminal and non-inverting terminal, this is nothing but offset current. So the minimum value of the offset current to make your output is zero. You want to give it in external manner, that is the 200 nano amps. Now third one, input bias current. Input bias current means average of the input bias current flowing to the inverting terminal as well as the non-inverting terminal also. So this also the maximum value gives for the input bias current to make your output is not equal to zero case. Now that time you want to reduce in the input bias current, how much of your current you want to give means 500 nano amps. Now we can go for that input resistance in different between the input terminals, like inverting input and non-inverting input terminals. So basically ideal cases the input resistance is infinity. In practical cases, you can give your biasing voltage to bias the transistor used in the fabrications. So you want in the active mode. So that time the input resistance between the terminals, input terminals is 2 mega ohms. Now, the next parameter is open loop gain. So, the gain output by input factor is the gain. We already discussed that the gain is infinity in case of the ideal characteristics. Now, we can go for the practicals. We want to analyze the two gain. One is the open gain, another one closed gain. So, in this closed gain is stability purpose we can use it. We will see the next video. Now the open loop gain. The open loop gain formula, the open loop gain V0 by VD. The last parameter is output resistance. Output resistance for ideal case of IC741 is low only. Okay, that means 0 is a low only, because of we can assume that the difference of the input given to the operational amplifier 741 is 0 I said. So that time is a minimum only you can get it. So 75 ohm is the output resistance for the IC741. Next, so you want to adjust this offset bias current or offset voltage or offset current. You want to use the potentiometer between the input terminals along with the supply voltages. Next, the last things, thermal drift. Thermal drift means variations in the temperature. It may be a room temperature or in the circuit. We can IC we can use in that any circuit, any applications point of view. You keep your temperature range is minimum only. So that value is 25 degrees Celsius. Belongs above this 25 degrees Celsius, what will happen? Unnecessarily the bias current or offset voltages or current will be increased to output is not equal to 0 when the difference of the input signal is equal to 0 cases. So you want to nullify these things, unwanted voltage, offset current as well as that voltage. So that's why that offset null will be available in the one of the pin of the IC741. IC741 pin details. The first pin is offset null, second pin is inverting amplifier, third pin is non-inverting amplifier, then this fourth pin we can use for negative supply voltage, and fifth pin offset null, and sixth pin is the output, and seventh pin is the plus VCC positive supply voltage, that is higher voltage, and then eighth pin is no connection. So according to these DC characteristics, you want to nullify that input bias current, input offset voltage, output offset voltage, and thermal drift. Due to the thermal drift, the output also not equal to 0 cases when the input difference is 0. So you want to nullify this, you can using the offset null pins, pin number 1 and pin number 5. Now the next you want to go for the AC characteristics of IC741. AC characteristics means you can give your AC signal, then you can analyze what are the parameters you want to measure from the AC signal, like a bandwidth and the frequency component. The bandwidth, do you know that bandwidth is a frequency difference, higher frequency and lower frequency. So in generally the bandwidth of IC741 in ideal cases is I said 0. So now we want to go for this AC characteristics analysis. That first one gain factor, second one slew rate, and gain bandwidth product. So this is a equivalent circuit. In this equivalent circuit, input voltage we are given V1 and V2. The difference is VD. Then the input resistance of the IC741 internal resistance is Ri. Then output resistance is R0. Now this is nothing but that voltage across the output terminal. So VAOL, that means open loop gain is equal to the difference VD, the output voltage gain is equal to output divided by input. Output divided by input means V0 divided by VD. So your AOL is nothing but V0 divided by VD. So here input given is AOL into VD. Now, so this is the frequency response of the IC741. So IC741, this is the open loop gain versus different kind of frequencies. Whenever the frequencies increases, in case you are using that IC741, what will happen? The gain will be decreased in your minus 10 decade per dB. Now, slew rate is an important parameter you want to analyze in that AC signal characteristics of the IC741. In this, slew rate is defined as the maximum rate of change of output voltage with respect to the time t. The slew rate is specified by the unit is volt per microseconds. Slew rate is the rate of change of voltage with respect to the time t at maximum condition. Full small steps changes what will happen in that output voltages. For example, they given that slew rate in a capacitor. When the AC signal is applied to the capacitor, what the slew rate? That is a formula. The rate of change of voltage across the capacitor with respect to the time t. So this is equal to, we know that formula for I, the relationship between that I and voltage along for the C. So I is equal to C into dV by dt. So according to the formula, the slew rate is equal to I by C. So at maximum current changes with respect to that voltage capacitor charging or discharging. So this is nothing but the slew rate. So you want to analyze the slew rate for the given AC signals. So you can assume that the AC signal given to that IC741, the Vs input AC signal is a Vm sin omega t. Then output, you can imagine that output also you can get it the sine wave. Now you want to find out that slew rate, the maximum rate of change of output voltage with respect to the time. So how can you find out this one? dV0 by dt. Now we want to differentiate that output voltage. Now differentiate the output voltage is nothing but Vm omega cos omega t. Now you can coming to that S. So S is equal to, you can cos omega t, the angular frequency, you can assume that the omega t is equal to 0. So cos 0 is equal to 1. So S equal to Vm into omega. Omega is the angular frequency, 2 pi f maximum frequency range. Now from this, the S is equal to slew rate is equal to 2 pi f Vm volt per seconds. But slew rate of the AC signals given to the IC741, the unit is volts per microseconds. So you want to convert it into that microseconds. So that's why the formula it becomes coming that finally Fm is equal to, the maximum frequency is equal to S divided by 2 pi Vm. So you want to multiply it with here microseconds. So S is equal to 2 pi f Vm divided by 10 power 6 also we can do it. Okay. Now, so this is nothing but slew rate. Now, gain bandwidth product. The gain bandwidth product of an op-amp, when the voltage gain should be in that unity cases is a 1. So, in terms of the decibels, we can call it as gain unity bandwidth. That means closed loop bandwidth. Now the feedback. So in case of the AC characteristics analysis point of view, the most important thing, we can measure the frequency as well as the bandwidth. So if we are increasing the voltage gain, what will happen? The increase that voltage gain, it affects the bandwidth frequency of these signals. Otherwise you can say when the bandwidth is increases, the voltage gain is instable. So you want to maintain your stable output voltage or stable gain, you can go for the frequency compensation techniques. Okay. Now not only the frequency compensation, we can go for the stability of voltage gain. You can use that feedback mechanism also. In generally, the feedback is nothing but the output is given to the input terminal. The partial output is given to the input terminals. So it may be happen in two ways. One is a positive feedback, another one is negative feedback. Now the positive feedback in case of the IC741 operational amplifier, the positive feedback is nothing but the part of the output through the feedback networks, we can give it to the input non-inverting terminal. This is the positive feedback. For stability purpose we can use it. Negative feedback means similarly the output fraction of the output is given to the input inverting terminal via the feedback networks. That means feedback resistance. So the feedback system to stable your voltage gain at high frequency range or particular bandwidth. Now, so these are the things, characteristics of AC and DC for IC741 operational amplifier. Now we can go for the simple applications of IC741, that is operational amplifier. We can perform the mathematical operation, addition, subtraction, scale changer, multiplication, division, multiplier, frequency multiplier, I to V converter, current to voltage converter, voltage to current converters, filter designs, next in sine wave signal generator, waveform signal generator. So many applications are there. So we can use only the first thing is we can discuss the basic application of IC 741, that is scale changer or inverter, summing amplifier, then subtractor, adder and subtractor. First one. So this is the basics thing of operational amplifier. The operational amplifier, you can default, you can give you a DC voltage for biasing purpose. For this kind of IC 741, we can use as a voltage follower. Voltage follower is nothing but the output voltage is equal to input. That means the gain of this circuit is equal to 1. So when this gain of this circuit will be 1, so you can give you a feedback signal. So this feedback output is given to the inverting input terminal. For this diagram, we can use as a voltage follower. These applications we can use for the buffer also. Buffer is one of the digital components, the digital circuit. Just you can store your data 1 bit because it is nothing but output equal to inputs. Okay, so there is no current drawn because there is no any resistance and all. Directly you can give your input voltage to the inverting terminal. The output you can get it. The output is same as an input terminal. Now, this case we can introduce the feedback in a negative manner. So, negative feedback we can introduce. So, in this negative feedback, you can stable your voltage gain. So, in this negative feedback, the output partially is given from R1 and R2 is connected to the ground, and in between that R1 and R2, you can connect it to the inverting input terminals. Okay. So, this is that you can give your output. Feedback is given to the inverting terminal. You can give your input voltage to the non-inverting terminal. So input is given to the non-inverting terminal. We can say this is a non-inverting amplifier. These are the basics. Then we can give you a non-inverting amplifier. For this non-inverting amplifier, the output voltage is equal to input of 1 plus feedback resistor. That means R1 divided by R2. Now, the next one, inverting amplifier. Inverting amplifier, we can give your output is given to that, output is given to the inverting terminal through the feedback, and then input is given to the inverting input terminal through that R1 resistor. In the non-inverting terminal, you can connect it to the ground. So it behaves like a inverting, it's a scale changer. Why I am telling that this is a scale changer means, we can give your input is positive to the inverting terminal. That means negative sign. We can get it that output in a negative sign only. That means 180 degree phase shifted. So that's why it's nothing but the scale changer. The scale changer, the output is equal to, so minus V in. The output is equal to gain into input voltage. The output voltage is equal to gain into input voltage. The gain parameter is nothing but RF divided by R1 into input voltage. So the negative will be coming because 180 degree phase shifted is happened. The phase shift between the output and input is 180 degree. Why means you can input is given to the inverting terminals. Now, so this is a simple concept of summing amplifier. This summing amplifier is categorized into two. One is the inverting summing, another one non-inverting summing. Inverting amplifier, so you can give your feedback in that inverting terminal as well as the input also given to the inverting terminal. You can keep your non-inverting terminal is grounded. That means no voltage is applied. Now in that case, the output voltage is equal to minus, because you can give your all the inputs to the inverting terminal. So you can get it that answer in a negative sign. So minus V1, the gain factor is RF by R1, minus V2, second input voltage, the gain is RF divided by R2, minus V3, the gain is RF divided by R3. Thank you. So we will continue in the next video. Thank you.